Okay, in this video here, we're going to be talking about evaluating functions and solving functions for different y values. So it's important to understand when you're being given an x value and asked to find a y value, and when you're being given a y value and asked to find an x value. Okay, so if you look at this, these are x values. So in each of these problems here, we're given an x value and we're asked to find the y value. Okay, this one says when x is 4, what is the y value? So to figure that out, we're going to plug your x value, in this case -4, into your equation. Okay, and so formally, f of -4 equals -2 times -4 plus 3 squared plus 4. Okay, so now we have to evaluate this, and this is just a matter of order of operations. So we're going to first do our parentheses. So -4 plus 3 is -1. Okay, and next we're going to do our exponent. So we're going to square -1. -1 squared is +1. Okay, and then we're going to multiply here, right? This is our next thing, is to multiply those guys together, and that just gives us a -2 plus 4, and now we're going to finally add, and that gives us a value of 2. Okay, so formally speaking, we could write that f of -4 equals 2. Or when x equals -4, the y value for our function is +2. Okay, so we're going to do that for both of these next ones. Plug in 0 and plug in -1. Okay, you can pause the video and try it. I'm going to give you the answers all together shortly. So there is the work and the answers to your next two things, right? You're plugging your value, right, your x value, into the equation. So we are evaluating our function at different x values. Okay, so the next question says, when you find the value of f of -4, the value of x equals -4. What does the result represent graphically? Well, graphically, it represents the y value of the graph, right? Where does the graph go? So it's the y value of the graph at x equals 4, or -4. Okay, so when you plug that in, you're finding the y value, right? Every time you get a point. So this is the x value, and you are calculating the corresponding y value that goes along with it. Okay, so let's see. So here's our picture. Here's our graph, -4, and when x is -4, let's look at the y value, right? And we get a y value of +2, which is exactly what we saw when we did our calculations. Okay, when we plugged in -1, and we got a y value of -4, which is the coordinate there on your graph. Okay, and of course 0, we can't see 0, that's -14, it's way off down there. Okay, so those results do make sense because the y values that we calculated are the y values on your graph for each of these particular given x values. Okay, so they always match up. Okay, so the graph clearly crosses the x-axis at the values of -4, -1. Based on your computations, how can you justify the guarantee? What does this say? The graph f of x clearly crosses the x-axis at a value between -4 and -1. Yes, it does. So that's just saying, look between -4 and -1, and you see that the graph crosses the x-axis, right? Somewhere in here, right there at that point is where the graph crosses the x-axis. So based on your computations above, how could you justify the guarantee of this occurrence? So let's look at the y values at the given point. So we have the point -4 and 2, which is here, right? So 2 is above your x-axis. At -1, our value is -4, which is below your x-axis. So somewhere between above and below, since your graph is continuous, right, it doesn't have any gaps or jumps, somewhere between -4 and +1, your graph has to cross the x-axis. Okay, it has to. In order to go from a positive value above at -4 to a negative value at -1, your graph has to cross the x-axis sometime. Sometime it has to be 0, right? Your y value has to be 0 at some point in there. So based on the graph, we cannot determine exactly what the zeros of the function are, but according to the graph between what two pairs of x values does a function lie. Okay? So we already determined that it was between -4 and -1. Probably a better interval might be from -2 to -1. Okay, because you have a positive value at -2, a positive y value at -2, and you have a negative y value at -1. So that similar thought process, that if we have a positive y value at -4 and a negative y value at -5, then somewhere between -4 and -5, you're going to have a place where the graph crosses the x-axis. In other words, where y equals 0. Okay, so that might explain that bottom one. So let's continue on with our discussion here. Let me move these things out of the way a little bit. Okay, so here's your graph by substituting in. So now we're going to solve for x. We're going to be given a y value. Okay, this is a y value. And we're going to ask to solve for x. So can you solve an equation f of x equals 0? When you solve the equation, what do the results represent for the graph? Okay, so when you solve x equals 0, you are finding the x-intercepts of the graph. Okay, where does the graph cross the x-axis? At those points. You are answering that question. Where does the graph cross the x-axis? Right, you are solving that, you're answering that question. Where are these two values where the graph crosses your x-axis? Okay, when you solve the equation f of x equals -4, what do the results represent graphically? So f of x equals -4 might be more familiarly written as x equals -4. Okay, so y equals -4. So y equals -4 is the equation of a horizontal line. Okay, so we draw in that horizontal line. Here is the line y equals -4. If we solve that equation, we're going to figure out what are the x values from your graph where the y values are -4. Okay, so that's the result. Those are the x represents the x-axis, the x-coordinate where your graph has a y value of -4. Okay, in other words, that would be at -5. Okay, that's the first point here where your graph crosses. Right, that's the x value, and the other x value is -1. So x equals -5 and x equals -1. Those are the two places on your graph where the parabola crosses your horizontal line y equals -4. Okay, so solve each of the following equations. What we're going to do is you plug in 0 for y. So 0 goes here. Okay, and of course we have -2 x plus 3 squared plus 4, right? This is our equation. We're going to solve this equation and figure out what your x-intercepts are, okay? So first of all, we're going to subtract 4 from both sides. We want to solve this for x, so we do all of our most simple algebra first. Now we're going to divide both sides by -2. Okay, and that's +2 equals x plus 3 squared. So now we have to get rid of that square, and you get rid of a square by square rooting. Okay, so the key to remember is when you take the square root of a number and you're solving, you're going to get positive values and negative values. Okay, that's the key to remember. Anytime you're solving an equation by square rooting, you're going to get a positive value and a negative value. Okay, now I'm going to open up my calculator real quick so that I can figure out what the square root of 2 is, because that's not a nice square root. Okay, but my calculator can tell me the square root of 2 is 1.414. Okay, so I'm going to make two equations. Positive 1.414 equals x plus 3. And the other equation, negative 1.414 equals x plus 3. Anytime we are solving by square rooting, this is what we do. Okay, and then to finally solve, we're going to subtract 3 from this. So when I subtract 3, I get an x value of negative 1.586. So that's one of my x-intercepts. And then when I subtract 3 from this, I get negative 4.414. Okay, so let's look up here at the graph and see if this is about right. Negative 1.5 and negative 4.4. Is that where these look like they cross the x-axis? Sure enough, this looks like negative 1.41 or 456, I think I was, maybe. Right? That looks like about right. And negative 4.414. Yeah, that looks like it's about 4.414. Okay, so when you solve this, we are figuring out where our graph crosses the x-axis. Okay, so when we solve our next one down here, we're going to figure out where this graph crosses the line x equals negative 4. Okay, so we're going to figure out these two values right here and there. Okay, so hold tight. I'm going to do it. Pause the video. Do it yourself. Sorry, this is not right. I want this number to be negative 4. Right, we want the y value to be negative 4. So sorry, I put 0 there. Okay, negative 4. When is that equation equal to negative 4? So let me do the algebra. You do the algebra. Pause the video. Come right back to check your answer. And there we go. So I noticed that I had a minus when it should have been a plus. Okay, I changed all of these here. So with a plus, you do get an x value of negative 1, and you do get an x value of negative 5. Okay, so looking back up at the graph, those are in fact the x values where your 2 points cross your line y equals negative 4. Okay, so solving an equation means that we are finding the x values where the y is equal. So in summary, when you evaluate what does it represent graphically, it represents the intersection of your graph and whatever line we are talking about. Okay, is it the x-axis where y equals 0? Is it some other y equals line? And there you go. Okay, and I believe the next thing says when you evaluate f of a, that represents a point, right? You are calculating a point on the graph. When you evaluate f of a, you get a point, and when you solve the equation, you are finding the intersection of your graph and that particular line, that particular horizontal line on the graph. Okay, let's look at our last page and see what this says. Oh, now we're changing up our function. Now we have an absolute value function. So let's just use our graph to do this. So we want to find the value of g of negative 6. So what is the y value when x is negative 6? And it looks like that point is right here. So we're going to write that g of negative 6 equals negative 1. Right? That's the y value right there. Okay, find the value of g of 1. So g of 1 is over here. There's your x value of 1. It looks like g of positive 1 equals negative 2. That's the y value. The y value is negative 2 when x is positive 1. For what values of x does g of x equal negative 4? So remember, we're going to draw in our horizontal line that is represented here. So remember, g of x is y, so we draw a line through negative 4. And it looks like the x values where it crosses are x equals negative 3 and x equals -1. Those are the two x values where your y value is -4. Okay, from our graph. For what value does g of x equal 5? Okay, so we draw in your horizontal line, and you see that is 5 only at one spot, right there at the vertex. So that x value is -2. Okay, so we have another one. So we're looking at the graph, right? Where does your graph intersect these horizontal lines? Whenever we have g of x or f of x or whatever, you're talking about the horizontal line because this represents the letter y in your functional notation. Okay, so lastly here we have a negative square root graph. Find the value of h of -1. So when x is -1, y is right in there. Okay, which is not exactly nice. So we can do this. We can plug it into our function, -1 plus 6 plus 3. Okay, and we can evaluate. -1 plus 6 is 5. The square root of 5. Once again, let me go to my calculator over here, sorry, and do the square root of 5. My calculator says that is 2.236. Okay, so now I'm going to multiply that by -2 and add 3. And this says I have a y value of -1.472. Okay, which looks like it's about 1.472, right? I would guess that that's -1.472 as my y value. And h of 10, well, h of 10 is not on the graph, so this is definitely something we have to do algebraically. Okay, so I'm going to do it and be right back. So this would give me a y value of -5. Okay, so now it says for what values of x does h equal 1? So remember, we're looking for the horizontal line through y equals 1. Okay, and our graph is going to tell us that that happens at x equals -5. Okay, but what does that look like algebraically? So we're going to plug 1 in here for h of x. So 1 equals -2 square root of x plus 6 plus 3. Okay, so it's algebra this, well, -3 from both sides. Okay, -2 equals -2 roots of x plus 6. Okay, divide by -2. I get 1 equals the square root of x plus 6. So now we're going to solve this square root by squaring both sides. Okay, it doesn't really change 1, right? 1 squared is still 1. So 1 equals x plus 6, and when we subtract 6, we get exactly what we expected. The x value, when y is +1, is -5. Okay, so some algebra there with our square root. And our last one, when is x equals -3? Okay, we can probably guess that is going to happen here, but let's just verify, right, algebraically. We want to know when this equation equals -3. Okay, so this is where we start off with, and we do our simple subtraction, and then we do our division, and then we do our squaring to get rid of the square roots. Okay, we square both sides here to get rid of the square roots. Square here, square there. And these undo each other, right? They're inverse operations. So then we have 9 equals x plus 6. And when I subtract 6 from both sides, I get 3, which is exactly what I had thought about looking at the graph, right? The graph says x equals 3. Okay? So remember, when we are solving an equation, we are finding out where that horizontal line crosses your graph. And when you are evaluating, you're plugging x into your equation so that you can get out a y value. Okay? There you go. Hopefully that helps, and we'll see you on the next video.